Determine the equations of the asymptotes for the hyperbola defined by the equation 3x squared minus 16y squared minus 18x plus 32y plus 20 equals 0. All right. If you're looking at this and saying, that doesn't look like a hyperbola, you're absolutely right. Hyperbolas are supposed to look like something squared over something minus something squared over something equals 1. And that's not this at all. So this is what we have to do. We have to make it look like that. And this is the process that we do it. Group your x's first because that's just what we do. 9x squared minus 18x. Group your y's, so negative 16y squared, positive 32y. And let's subtract 20 from both sides, equals negative 20. Okay, now the first thing that we're going to do in order to make it look like a parentheses over a number or whatever is we're going to factor out the 9. So factor out the 9, that leaves you with x squared minus 2x. Okay, now what we're going to do is we're going to factor out the negative 16. That's where our negative comes from. So minus 16y squared minus, almost put a plus there, that was a close one, minus 2y equals negative 20. Now, I'm not where I need to be. I'm not at all where I need to be. So this is what I need to do. What I need to do is I need to, inside this parentheses, I need to kind of combine or complete the square rather. So what that usually looks like is I take a number, right? And I take the number in front of x, take half of it, so negative 1, square that, which is 1, and add that to both sides. So if I do that, okay, if I take half of negative 2, which is negative 1, square that, which is 1, and add that to both sides, I'm adding 9 to both sides. Why 9? Well, because inside the square root, or inside rather the parentheses, I'm adding 1. So if I were to distribute that, I would be adding 9. So I have to add 9 to both sides. Similarly over here, the same thing is going to happen. Minus 16, take half of the number in front of y, which is negative 1, square that, which is positive 1. And by doing that, minus 2y plus 1, I am subtracting 16 from both sides. Okay, so now what I get is sorry, I'm switching colors, 9x squared minus 2x plus 1 minus 16y squared minus 2y plus 1 equals negative 36 plus 9 is negative 27. Now, here's the difficulty of this problem, okay? This has to equal 1. So it's not a matter of getting rid of these guys and having like nothing in front of my parentheses. This has to equal 1. So let me quick do what I'm supposed to do here first. X minus 1 squared minus 16y minus 1 squared equals negative 27. So what I have to do is I have to divide everything by negative 27. Everything by negative 27. Everything by negative 27. So that's good here because this becomes negative. Now I have to change things around. X minus 1 squared over 3. However, that doesn't happen here, okay, at all. In fact, there's no simplifying whatsoever. So what I do is I make this y minus 1 squared, and instead of 16 over 27, I have 27 over 16 on the bottom. I have the reciprocal. So ideal? No. But does it do the job? Yes. Yes, it does. And now it equals 1. So rewriting it now that I have a negative here and I have a positive here, I now have a hyperbola in the form y minus 1 squared over 27 over 16 minus x minus 1 squared over 3 equals 1. An equation where the y part comes first, then the minus sign happens, gives you vertical or slant asymptotes at y equals plus or minus a over b times x minus h plus k. Okay, now my A, B, H, and K are all found by looking at these guys. Okay, when it's the y first, it's y minus k, so k is 1. Okay, this is going to be my A. So a squared equals that, which means A, let's put it over here, is going to be the square root of that. So the square root of 27 over 16 is going to be 3 root 3 over 4. So that's a mess. So that's A. A equals that. H is going to be positive 1. So that's good news. And B is going to be the square root of 3. So y equals plus or minus a, which is the square root of 3 over 4 over the square root of 3, which is kind of good news, times x minus h, so x minus 1 plus 1. Now let's take this chunk over here. Let's erase this so I can give myself a little bit more space. Okay, in order to deal with 3 root 3 over 4, I have to multiply the top and the bottom. So I'll put that over 1. I'll multiply the top and the bottom by 1 over root 3, 1 over root 3, which means a lot of canceling out happens. Okay, so all of that's gone. And now I have 3/4. So my final answer is going to be y equals plus or minus 3/4 x minus 1 plus 1. And I'm not even going to consider splitting that up into 2 equations and do the positive version and the negative version because the whole thing is just a mess. But there you get it. It's awesome.